Oh, hey, it's Dr. J. 4.3. We're moving right through chapter 4. Multiplying and dividing mixed numbers. I didn't have room to write the whole word numbers, so I'm using the old-fashioned number sign. I guess they call it a hashtag now, but I still refer to that as a number sign. Okay, I don't really have a backstory. I don't have a big, long introduction. We've talked about mixed numbers. We've talked about fractions. It's basically the topic of the entire chapter. I'm going to get right into it with an example. Let's start with multiplying. So we got 4 3/5 multiplied by 5 2/3. The first thing I want to point out in this section is even though we are calling them mixed numbers, and we're saying multiply, divide the mixed numbers, you're not actually going to do that. You're always going to rewrite as an improper fraction. So if you actually try to multiply these, you will more than likely make a mistake. I know that I would. I don't really know a very efficient way of doing it other than rewriting them as improper fractions. So a quick review, you multiply the denominator times the whole part, and then you add the numerator. So you've got 23, and then you keep the denominator the same. So that's 23 fifths multiplied by, same concept here, multiply and add. So you've got 15 plus 2, 17 thirds. Now do yourself a favor, write them out as 23 times 17 and then 5 times 3, and try to reduce, also known as simplify, first. All right, before you do any multiplying, try to simplify. All right, 17. Can I break that down into any smaller numbers? No, it's prime. Yeah. 23. Can I break that down? No. We really got a real stinker here. 5, no. 3, no. Well, but I at least tried. And then I have no other choice. I have to multiply these. The denominator is 15. That's easy. The numerator, I'm going to use a little scratch work over here. 23 times 17, probably going to need more room than that. If you want to break out your phone or calculator, you certainly can. 7 times 3 is 21, carry the 2. 7 times 2 is 14, plus 2 is 6. 1 times 3, 1 times 2. Add these up. You get 391. Okay. So you're going to rewrite as an improper fraction, then write the answer or the result as a mixed. So you're basically going mixed number into improper and then improper back into mixed. So now we want to write this as a mix. So we've got 15 into 391. Now you can do this with a calculator. Multiplying. Calculators work great for multiplying. Do not do the division on your calculator. You will not get the right answer if you try to use your calculator for the division. All right? Calculators work great for multiplying, but not for dividing, because when you divide, you'll get decimals, and if you get a decimal, I'll immediately know it's wrong. and so will the computer. Okay. Now, once we get to the chapter on decimals, then you can do that. So 15 goes into 39 twice. Remainder 9. 15 goes into 91. How many times? 6. 6 times 15 is 90. Remainder 1. So your final answer is 26 and 1/15. That's the answer. Remember, C, A, B. C, A, B. Just a quick review of how we did that. So that's C, constant. That's your whole. A is your dividend or your numerator, and then 15 is the divisor, denominator. Okay, well, I mean, that is your introduction to the section without really having to tell a big story. I just do a problem, and this is basically what we're going to be doing. So, let's try another one. Example 2. 6.5 divided by 2 3/4. Come on back. I just made it worse. There we go. All right. So let's turn these into impropers. So that would be 13 over 2. Yeah, 2 times 6 is 12, plus 1 is 13 over 2. I'm not going to change it yet. I'm going to keep it as divided by for one step, and then I'll change it in the next step. I used to think I was slick, and I would try to, change it now, because you remember the rule is to flip it and multiply. But typically what happens is you'll flip it, and then you'll screw it up, and you'll just wish you would have waited a step. So 4 times 2 is 8, plus 3 is 11 over 4, and then now flip. So change to multiply and reciprocate. The reciprocal of 11/4 is 4/11. It's called flipping. And then change to multiply. All right, multiply straight across. All right, and then try to reduce. This time I have a number that can be factored. So I factor the 4 as 2 times 2. The rest of it's already factored. 2 times 11 and the 13, those are already prime. And then cross off a pair of 2's. So 13 times 2 is 26, and then the denominator is 11. Now you want to write this as a mixed number. Again, if you just put this in your phone, 26 over 11, it's going to fill up your screen with a bunch of decimals, and you're going to go, what the heck is that, right? It's got to be something wrong. So 11 goes into 26 2 times. 2 times 11 is 22, remainder 4. So this is 2 4/11. All right, not too shabby, huh? Notice a lot of things about mathematics that I think are much more important than simply getting the right answer. Look at it. Equals, 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 equals. Nice lined up. They don't have to be perfect, but relatively organized equal signs. I'm not doing more than one thing per line. I don't want to get all sloppy and lose a bunch of my numbers. All right. One thing that happens is sometimes your brain will try to trick you. Your mind will say, hey, I'm going to skip a bunch of steps. I'm going to see if I can cram it all into one step and I'll get the answer quicker and I got a deal. But you're not getting a deal. Yeah, that's like stealing from yourself and then thinking that you got something out of it, right? But you just stole from yourself. You're not really getting anything when you do that. All right. Most important part of this class is it's the most important class in your entire education. If you learn how to do this correctly, you can breeze through the rest of your math classes. But if you do this class, and you steal from yourself all semester long, then it's just going to make life harder in the future. I know, I sound like a dad, but, I might see some of you in the future in my class. I'm still going to be here for another 15 years, so I'm planting the seed now. We will harvest later. All right, let's do a couple more of these. So how about this? 4 3/5 divided by 2. Four 3/5 divided by 2. Well, first we need to turn this into an improper. I think we've seen that one before. 23/5. 5 times 4 is 20 plus 3 is 23/5. Keep it as divided by for a second. Then flip. Two over 1 becomes 1/2. Then multiply straight across. It's not reducible, so I'm just leaving it as 23 over 10. And then finally, let's do this whole thing mentally. Yeah, 10 goes into 23 2 times with a remainder of 3 and a divisor of 10. 2 3/10. When we get to the chapter on decimals, we'll write this as 2.3. Yeah, 2.3, which is what your calculator would have given you, 2.3. As long as you know that 0.3 means 3/10, then you probably could have pulled it off. Yeah, but that's very rare that the calculator will actually give you nice numbers like you're expecting. This is one example where you would have gotten 2.3, which is the same as 2 3/10. 3 1/4 times 2. Yeah. By the way, I don't want to ever rob you of your humanity, okay? You are a human being, okay? So I want you to think. Sometimes algebra and arithmetic are very mechanical and you're just sort of acting like a machine that's following a bunch of steps. But remember, stay human. Right? You make a guess as to what you think is going on. 3 1/4 times 2 should be 6 1/2. So I haven't done anything except think like a human being. 6 1/2. I think I'm going to get 6 1/2. Let's do the math and see if we get 6 1/2. All right. That is much more important than any math class. Is that you remain human. And that you can actually look at something and think about it like a person. I mean, this is all made for you. I'm not doing this for me. I'm doing this for you. Okay, so we should get 6 1/2. If we don't get 6 1/2, then we know we did something wrong. All right, let's see. So 3 1/4. Let's see. That'll be 13/4. Yeah, 3 times 4 is 12, plus 1 is 13/4. 2 over 1. Okay, this is not division, this is multiplication, so I'm just going to go straight across. All right, it's factorable. Yeah. So 4 becomes 2 times 2. And now I can cross off a pair of 2's. That's a special factor of 1 or a special form of 1. So I multiply, I get 13 because that's all that's left on the top. And then 2 times 1, I really didn't have to write the 1 because 2 times 1 is just 2. And now when I do my division, I better get 6.5. 2 goes into 13 6 times. 6 times 2 is 12. 13 minus 12 is 1. 6 and 1/2. A calculator would have given you 6.5. All right, and as long as you recognize that 0.5 is the same as 1/2, then 6.5 it is. Okay, those first 4 examples really kind of sum up the entire section. The rest of the problems, I'm just going to bring in other concepts like negative numbers, vocabulary, maybe some geometry, things like that. So let's bring in the rest of the team, the rest of the operations that we've learned, and let's put them all together. All right, so I've got negative 2 1/3 divided by negative 3.5. The parentheses are not required, but they're just there to sort of keep your eyeballs on what you're doing. So it's basically telling you, okay, it's this negative number divided by that negative number. It's to prevent any ambiguity. You can actually remove the parentheses now, okay? In fact, I'm going to. First thing you want to do, before you do any math, decide if the answer is positive or negative. Yeah, and I'm just reviewing the old rules. We are dividing, so make sure you know what you're doing, and you're dividing a negative divided by a negative. So you already know the answer is going to be positive. So now we can cross off those negatives, and we know that our answer is going to be positive. So now, remove the parentheses, turn these into improper fractions. That one's 7/3, and this one is 7/2. All right, that's important that you ignore the negative when you do that. So it's 2 times 3 plus 1, that's 7/3. 2 times 3 plus 1 is 7/2. Coincidence, they both have a 7. So 7/3 times 2/7. Yeah, switching and flipping. Multiply straight across. Before you multiply, take a good look at it and say, can I simplify this? You can simplify that, and the answer is 2/3. This is a proper fraction, so cannot be mixed. So if you can't make a mixed number out of it, well, then you can just leave it alone. And again, all of these rules are just instructional. So if you read the instructions, it should clearly say. Some problems don't have specified instructions, and that really leaves it to you to decide how you want to write your answer. All right. There's only one unwritten rule, and that's that all answers must be simplified, even if it's not specified. Simplified answers are implied throughout the remainder of this course. So you would never want to leave it as, 14, like 7 times 2 is 14. 3 times 7 is 21. If you tried to go away from it at that point, 14 over 21 would not be marked correct. Okay. But 2/3 is. Okay. This one, in this problem, the parentheses are very important. Yeah, because if you didn't have those parentheses, this would mean subtract. But parentheses override any of the other operations. Parentheses automatically imply multiplication. All right. There is no symbol here. So if you don't see a symbol and you see two objects next to each other, in particular with parentheses, you assume that means multiplication. So now we have a positive and a negative. So decide, is it positive or negative? Well, you have a positive multiplied by a negative. So I already know my answer is going to be negative. All right. So let's put our negative sign down and don't forget it. You can ignore it for a minute, so don't look at it, ignore it, but don't forget it. All right. If you think you're going to forget it, then you have to carry the negative sign with you all the way down. If you're forgetful. I sometimes forget. I'm so bad that I will sometimes say, don't forget, and then I'll forget anyway. Yeah. All right. So let's go ahead and do it. We got 5 1/2. 5 1/2 is 11 halves. Yeah. 2 times 5 plus 1. I'm going to go ahead and switch to a dot for multiply instead of parentheses. Means the same thing. And then that'll be, 7/3 again. I feel like I've met you before. Multiply across, 77/6. That cannot be reduced. Don't forget your negative sign. So this would be an improper fraction. It is simplified. Or 6 goes into 77 12 times with a remainder of 5. 6 goes into 77 12 times. 12 times 6 is 72. So the remainder is 5. And so this would be the mixed number. For this particular problem, I'll give you a choice. You can either write it as negative 77/6, or you can write it as negative 12 5/6. I want you to see both possible answers. It's funny that we call this simplified. 77/6. It doesn't look very simple. So the word simplified does not always mean what it sounds like it means. Simplified just means that it cannot be simplified anymore. So this is a simplified improper fraction. This is a mixed number, which looks a lot simpler, but this is technically not called simple. This is called mixed. All right. So anyway, just want to throw that out there. What is the product of negative 2 5/6, negative 2 5/6, and 12? What is the product? Well, product means multiply. Product, produce. Produce the product. Multiply. Yeah. All right, so let's decide. We have a negative divided by a negative times a positive. So I already know my answer is going to be negative. Do that right away, and then I'm just going to ignore it, and I'm going to not forget about it. Okay, so out of mind, out of sight. So I've got 2 times 6 is 12, plus 5 is 17. And then 12 is 12 over 1. I'm not dividing, I'm multiplying, so I'm not going to flip this. I'm going to leave it alone. I'm going to try to simplify this. 17 times 6 times 2. And then the bottom is 6 times 1. I'm factoring the 12 into 6 times 2. Now I could keep going, right? 6 is not prime, but I've mentioned this in the past. If you already see a matching pair on your way to finding the factorization, you can stop early and kill it now. There's no point in continuing to factor once I have a match. If you don't see a matching pair, then keep on factoring until you get a match. Sometimes you just don't get a match. Like earlier in this lesson, there was a couple problems where there were no cancellations. All right, and so now we have negative 17 times 2 divided by 1. And so if the denominator is 1, the result is not a fraction, it's an integer. So we write negative 34. There you go. That's the product. Yeah. I'm a big fan of problems with words, so that you have to translate the problem and then solve it so that you're seeing the whole and you're hearing the whole story. I'm not a big fan of problems that you just simply follow a bunch of steps and get the right answer, because that doesn't really lend itself to future learning. It's just a process, but it's not useful. The most useful thing about math is more than simply finding the answer is learning the vocabulary, learning the terminology. That's what's going to pay the bills, That's what's going to get you that scholarship, That's what's going to get you into the university, is knowing how to say it right. Nobody cares whether you can do it. You got to know how to read and speak. All right. What's the quotient? 31 and 3 1/10. Quotient. Quotient means divide. Three and 1/10. So quotient means divide. Now let's do the improper fraction. 3 times 10 is 30, plus 1 is 31. Now don't cancel them yet. First you have to flip. Then you have to multiply. Now you can cancel. And so the quotient is 10 over 1, which is again an integer. It's a positive integer, also known as a whole number, but it's 10. Okay. All right, that's pretty much it for multiplying and dividing whole numbers. Now we're going to bring back some of our old friends. We're going to bring back the order of operations and some geometry. Okay. So we're going to simplify this using the order of operations. Now remember, the order of operations was please excuse my dear Aunt Sally. Yeah, parentheses, exponents, multiplication, division, addition, subtraction. But we've actually streamlined this into a new acronym: G, grouping symbols; E, exponents; M and D are just called M, and then AS are usually called A, or I actually like to call it S because then it spells the word gems. Yeah. So this means group, then exponent, then multiply, and then sum. Yeah. You could also say add, right? I think I did say that before, gemma, but I think it's cooler to say gems because it makes it sound important. These are gems. These are the things you really need to keep, in a safe place. All right. So first we're going to do grouping symbols, right? We don't really use the term parentheses very often. These are called groups. So you actually want to do those first. That counts as a grouping symbol. Yeah. The numerator is a group and the denominator is a group, and so we are grouping them together. So let's do that. Now what's really cool about the process of mixed numbers is the plus sign means and. Yeah, that's what the plus sign means. Some people even in shorthand notations, if you're a note taker and you're in a class and you don't want to write the word and, especially if it's not a math class, you could just use a plus sign for an and. Yeah, it means the same thing. At least in this context it does. All right. I know context is everything. 10 2/3 is a mixed number. Right? You say 10 2/3, 10 2/3. You don't, the and is implied. 5 6/7, 5 6/7. The and is implied. Ten 2/3 is 32/3. Yeah. 3 times 10 is 30, plus 2 is 32. So that's 32/3. 5 6/7. That's 41/7. Yeah, 5 times 7 is 35. 5 times 7 plus 6 is 41. 41/7. Okay. Now check this out. You're going to love this. 3 and 7. What is the least common multiple of 3 and 7? It's very simple because the least common multiple of two prime numbers, they're both prime. If they're not prime, it's a little more complicated, but we did discuss how to do it earlier in the chapter. But the least common multiple, if they're not prime, there's a few steps involved. But if they are prime, you can just multiply them together and get 21. Now check this out. You're going to multiply the top by 21, and you're going to multiply the bottom by 21. And I don't mean the top, I mean the top of the top and the top of the bottom. That's a mouthful, but... So only multiply the tops, the numerators, of the numerator and the denominator. All right? This is called a complex fraction. Some people call it a compound fraction. Just complex, compound mean the same thing. All right. So now you have 32 times 21 over 3 all over 41 times 21 over 7. I know you can't see that, so let's just... 32 times 21 over 3 all over. With complex fractions, you have to be really careful where the big division bar is, this one here. So I would always make that one extra thick so that you don't lose track of it. And then you've got 41 times 21 over 7. Now, if you do this correctly, the denominator should cancel. 21 is 3 times 7, so the 3's will cancel. I'm just writing my 21s from down here. I'm writing them as 3 times 7, and then I'm canceling the 3's, and then down here I'm canceling the 7's. So now I have 32 times 7 over 41 times 3. See if you can do any more canceling. If you can't, then you're done. 32 times 7 is 224. I just guessed. I should probably check that in a minute. 41 times 3 is 123. You want to double check these with me? Okay, 3 times 30. 3 times 30 is 210. Don't lose that. 3 times 30, 210. 7 times 30. 7 times 30 is 210. I don't know why I said 3 times 30. 7 times 30 is 210. All right, hold on to that, 210. 7 times 2 is 14. All right, so now you got 210 and you got 14. Double check. That's 224. Good. All right, let's try this one. 3 times 40. 3 times 40 is 120. Yeah. 3 times 1 is 3. So you got 120 and you got 3. 123. The more you know. In the next chapter, maybe, I don't know, I keep saying chapter. In the next lecture or the next section, I'm going to do more complex fractions. I'm going to move on away from that for now. Let's talk about geometry. I only have time to do like a little bit of each type of problem. So, trying to get this one done in under an hour. I know some of my other videos went on really long. So let's see. This is supposed to be one of the sections that does not take an hour and a half. So let's find the area. Find the area of a rectangle that is 8 3/4 feet by long. I was going to use an X for by, but it's okay. I'll just say it's 8 3/4 feet long and 3.5 feet wide. It might help if you just draw a little picture here, just so that you know what you're talking about. So you have area. Area is the inside, not the outside. That's perimeter. All right, and then the short side is 3.5. That's how wide it is, and how long it is 8 3/4. The words length and width are a little bit interchangeable. Typically, human beings consider the length to be the longer of the side and the width to be the shorter of the sides, but that's really just because the word long means longer in some sense, but that's not really a law. You could say that it is this wide and this long. You could call this the width. The bigger one could be the width, and the length could be the shorter one. It doesn't really matter because area is independent of order. It doesn't matter what order these are in. So the area is length times width. Yeah. And sometimes this symbol here is read as the word by. Yeah. So length by width. Yeah. It's the product. All right, so the area is, you could also just use the letter A for area. Length is 8 3/4. I'm going to use a dot for by, and then 3.5. Now, technically, we're also multiplying the feet. Yeah. So that's feet times feet. We usually put the units off to the right-hand side. I'll get to that in a minute. It really doesn't affect the answer. It just affects how we say the answer. So that's going to be 35/4. And that's going to be 7/2. Oh, we don't get any canceling. Look, 4 does not have a common factor with 7, and 35 does not have a common factor with 2. Bummer, huh? So we just have to do it. We're going to get 245. 35 times 7 is 245. 4 times 2 is easy. That's 8. This one's a little harder. 7 times 35 is 245. I'll leave that one for you guys to check. If I'm wrong, you might get extra credit, but I think I'm right. We'll see. Check me. All right, 8 goes into 245 30 times with a remainder of 5. And so you say feet squared. So the answer is 30 5/8 square feet. Why does it have to be square feet? Well, we'll get more into that later, but it's really for common sense purposes. If you go to Home Depot, suppose this rectangle is your bathroom or something. It's probably more like a closet, or maybe a small walk-in closet. It's kind of skinny and long. It'd be a pretty small bathroom. But anyway, suppose you wanted to put tile on the floor, or you wanted to put a rug, or you wanted to put carpet, or whatever you want to put out to cover the area. That's why we call it an area rug, right? You're not going to say, I want 30 5/8 feet, right? I mean, they would give you just a giant thing, 30 feet long. You don't want that. It's not going to fit. It's 30 5/8 square feet. It's as if the inside of the room were covered with these little squares. I'm not really going to do 35 little squares, but whatever. Okay, so that might be 35. 1, 2, 3, 4, 5, 6. No, it's not. It's not 35, but it's close. It's, I don't know, 30. So you have 35 of these squares right here. If I really want to make it 35, I'll add an extra row here. There we go. So that's 35 squares. filling the rectangle. And then you have 1, 2, 3, 4, 5. Those aren't whole squares. Those are eighths. Those are little strips. So at some point, I'm going to have to cut my carpet or my tile. If it's tile, they have a thing called a tile cutter. You can cut the tile to eighths, and you would lay 5 of these little eighths, an eighth of a tile. Hopefully it's carpet. It might be easier to cut, but it could be tile. It could be brick. It could be whatever it is that you're laying on the floor. Okay. All I care about in this lesson is that you get this part right, 30 and 5/8. We're going to talk about feet and miles and inches and meters and kilometers and all of that stuff later in the semester. So by the time I get there, you guys are going to be, you've been telling us about this since September. I have a habit of doing that. I think, I'm really bad at keeping a secret. If you were my kid, you'd probably already know what you're getting for Christmas, even though it's only October, Okay, let's find the area of a triangle. With the height, H for height, um, 6 3/8 inches, and B, 4 1/3 inches. All right, so maybe let's draw pictures to kind of give the idea. So here's the B, there's the H, and then your triangle kind of looks like this. And it really doesn't matter what the angle is. I mean, it could be a big, wide tent, or it could be a tall, skinny tent. I think of it like a tent. The height is the tent pole. It's like the center pole that holds up the roof of the tent. All right, and the B is the whole base, like this. So the area of a triangle is 1/2 B times H. Sometimes we like to throw in an extra dot right here just so that it looks like everybody's being multiplied. So we got 1/2 times 4 1/3. That's our B. And then we got H is 6 3/8. Oh, and these are both inches. So inches. Which is why we call them square inches, by the way. Because you're multiplying something that's inches times something else that's inches. And so when you multiply those together, you might as well just do that now. You're going to get IN squared, also known as square inches. A square inch is a little square. That's 1 inch on each side. You don't actually do anything with the A. The A is just an indicator that we're finding area. So you could actually just ignore this side altogether. Make sure you use everything we've learned in this lecture. So rewrite this as a improper fraction. That would be 13/3. Rewrite that one. That would be 51/8. Okay, multiply straight across. 1 times 13. You might as well try to reduce it while we're going, or you could wait till the end if you want. I'm getting real tight on space here, so I'm going to save a line and go ahead and reduce. So 51 is 17 times 3. That's one of those ones you just have to remember. 17 times 3 is 51. The bottom, there's not much you can do with the denominator, so I'm just going to leave it as 2 times 3 times 8. If I had more even numbers in the numerator, notice the numerator is all odd numbers. If I had a bunch of even numbers in the numerator, I mean, you might in your problem. It's kind of a 50-50 chance of whether you're going to get evens or odds. Then I would probably go a little bit more factoring. I'd break up that 8. So I know I've said this a lot, but I mean, how do you know whether you have to keep going or not? It's really up to whether or not you can keep going. I mean, there's not really much I can do. I've reached what we call it the end of the road, right? I mean, I've reached the end of the road. There's not much else I can do. So the only thing that I can cancel is I can cancel a pair of 3s. And that's really it. So this is 1 times 13 times 17. And then 2 times 8. Let's just get that over with. 2 times 8 is 16. 13 times 17. I'm not sure if anybody ever learned that one in elementary school. I didn't. Yeah. So 3 times 7 is 21. Carry the 2. 3 times 1 is 3 plus 2 is 5. Placeholder. 1 times 7. 1 times 1. 221. No wonder we never memorized that one. 13 times 17 is 221. Doesn't really run off the tongue very nicely. All right. And so this is square inches. I don't know about you, but I mean, if you went to Home Depot, right, or Lowe's or something, and you want to buy some carpet for this weird shaped room, I don't know, maybe it's like I don't know, I've never seen a room shaped like that, but maybe you're, have some weird house that's some, unusual shaped floor, and you want to put some carpet or some tile on it, and you go to Home Depot and you say 221/16. Can I get a manager to help me out here? Because I need 221/16. Hello, can I get a manager? Nobody, not even the manager is going to be able to help you. 221/16, what the hell are you talking about, right? So you have to write this in a way that makes sense to the average person. Remember, you got to be able to tell this to a person, otherwise it's meaningless. So I want you to write this as a mixed number. So 221/16, 16 goes into 22 one time. 1 times 16 is 16. 22 minus 16 is 6. Bring down the 1. 16 goes into 61. How many times? 3? Maybe 4? Let's try 4. 4 is too big, huh? Let's try it anyway. 4 times 6 is 24. Carry the 2. 4 times 1 is 4 plus 2 is 6. Too big. 64 is bigger than 61. I should have gone with my gut. My gut said 3. 3 times 6 is 18. Carry the 1. 3 times 1 is 3 plus 1 is 4. And so the remainder is 13. So finally, we have the area is 13 and 13/16 square inches. Or IN squared. You read that as square inches. right, that's it for geometry. If you're concerned or you're nervous about geometry or it's something, don't worry about it. I mean, I'm only going to give you 1 or 2 problems here and there. Typically, it's triangles and rectangles. I mean, that's about it. Occasionally, we'll do some weird shape like a trapezoid or a parallelogram or something like that just to kind of spice things up a little bit. But, I mean, I don't want you to lose any sleep over it. If you know triangles and rectangles, then that's pretty much Math 65's geometry, at least up until now. Eventually, we'll get to circles, but we're not even there yet. I mean, we've drawn circles, but we haven't actually, done much else with them but draw them. All right, the last thing is word problems. I know next to fractions, it's funny. This is really it, huh? Fractions, everybody loves fractions. Geometry, doesn't everybody love geometry? And word problems, the 3 most favorite topics of mathematics students all across the country. Geometry, fractions, and word problems. Yes, please, right? So, word problems. Word problems are really just like any other problem. It's just I state them in sentences in word form, and then you have to dissect all the important information and be able to solve the problem. Elephant grass. It grows very, very fast. It grows 2 1/3 inches each day. Or per day, or each day, or a day. Yeah. How many inches will it grow in 1 week? I notice I say every day, but you could also say per day. You could say each day, or you could say a day. Those all mean the same thing. Yeah. So what are we doing here? We are finding the product. Yeah. So think about it, right? You got 2 1/3, right, in 1 day. Then you got another 2 1/3, and another 2 1/3, and another 2 1/3, and another 2 1/3. 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days, and that's 1 week. Yeah. So it's going to go 2 1/3. This is called the product. Yeah. I guess you could add if you really want, but adding is harder. It's much easier to multiply. The product of 2 1/3 and 1 week. Make sure you don't use 1. You got to use 7 for 1 week. Sometimes I'll just tell you the number of days. I'll say 9 days or 8 days or 12 days. In this one, I said a week because I'm assuming a week is 7 days. Okay, we're going to multiply here. 2 times 3 plus 1 is 7, so it's 7/3. Times 7 over 1, which is 49/3. Yeah, 7 times 7 is 49. 3 times 1 is 3. And then now write this as a mixed number. 3 goes into 49. How many times? 16 times. With a remainder of 1/3. And that is not square inches because it's inches each day. So it's going to go 2 1/3, 2 1/3, 2 1/3, 2 1/3. After a week, it grows 16 1/3 inches. That's a lot. That's almost 1.5 feet in a week. I think that's why they call it elephant grass. I think I have time for one more word problem. A recipe calls for 5.5 cups of flour. Unfortunately, you only have a 1/4 cup measuring cup. Has this ever happened to you? You know, I know when you first buy the set, they're all a whole bunch of nicely stacked cups, and they go inside of each other, and you got the whole set, right? You got an 1/8 and a 1/4 and a 1/3 and a 1/2 and whatever, a whole, whatever. But suppose you lost all but one. So you've only got one measuring cup. Okay? But you need 5.5 cups. How are you going to get 5.5 cups using only 1/4 cups? So it's sort of like this. You need 5.5. Yeah. You only have a 1/4. How many 1/4s how many quarters, a 1/4 is also called a quarter, how many 1/4 cups would you need? Well, this is a quotient. It's the reverse of a product. It's a quotient. I'm trying to figure out how many I need. As opposed to the last problem, I already knew it was a week, and I was just trying to figure out this number, the larger number. Yeah. So we want to find the quotient. Quotient. There we go. Quotient is divided by. So you're going to take the total that you need, that's your dividend, and you're going to divide it by the number of cups, that's your divisor. And there you go. So 5.5. You go 2 times 5 is 10 plus 1. That's 11 halves. Divided by 1/4. That's 11 halves times 4/1. Remember to flip. Multiply straight across. That's 44 divided by 2. I forgot to reduce, but it's never too late. If you forget to reduce, don't stop. Do it at the very end. It's never too late to reduce. You can always reduce before you submit your answer. 44 divided by 2 is 22. So you need 22 1/4 cups. In other words, a lot more than I have in the picture here. So it'd be a 1/4, 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 a 1/4. All together, you would have 22 total scoops, I'll call them. I'm not calling them cups, I'm calling them scoops, because each scoop is a 1/4 of a cup. Well, we did it. Yeah, I got it done in less than an hour and a half. Just a little over an hour. So I guess I'll see you next time. But until then, this is Dr. J. I will see you on the internet.